Okay, so let's do part 2. What I want to do is start off by doing a problem real quick, just to review all the steps that we did yesterday. And
staff and students, if your car is parked on the north side of the building, it will need to be moved at this time.
North side of the building?
This side?
By the sidewalk? North side, no.
no, north I think is that way. It's by the road.
I'm parking on this church.
You park on the west.
Come on.
I park on the west.
Okay, guys, let's get going. So the first step is to write this in standard form. So I'm going to do that right here. You'll divide through by 36. Divide through by 36. Divide through by 36. And so that gives me y squared. Now 4 goes into 36 9 times, so there's going to be a 9 down here. Plus 9 goes into 36 4 times. So that's going to cancel and give you a 4 down there. So you're going to have x squared and a 4. And then over, whoops, there's no plus sign. Who put a plus sign there? What makes a hyperbola is that negative sign. Otherwise we'd have ellipses, right? So you have negative there, and there would be a 4 right here, and then equals 1. Alright, so at this point, step number 1 is basically done. The next step, I think, probably should be to get that box in there, because you're going to draw some asymptotes through the box. Now the box is quite easy, so this will be like step 2. If this is your a squared, then a is equal to plus or minus 3. And so since this is under the y squared term, we would put the plus or minus on the plus minus 3 on the y-axis. So there we go, we got plus or minus 3. Now likewise, you do the same thing over here. If this is your b squared, then b is equal to plus or minus 2. And so you go over here, put a plus or minus 2, and now we just make a box horizontal. Just extend the lines horizontally and vertically until they kind of intersect. Okay, and this isn't that easy to do on my sketch pad, so there's your box. Now after that, you want to draw in the asymptotes. Now the asymptotes go right down the diagonal, so sometimes you'll use a dashed line and to draw in the asymptote. That's fine. So you got this asymptote going. And you have an asymptote that goes down the other diagonal as well. So we'll just draw that in. Try to get this going here. Okay. Alright. And as you might imagine, there seems to be 4 places where the hyperbola could appear. 4 branches. But again, the only branches that appear are the ones that are on the transverse axis. This axis, the one that's positive, we would call the transverse axis. Transverse. I may have mentioned that yesterday, but anyhow, this axis over here, the one with the negative attached to it, right here, this negative, this is what we call the imaginary axis. And I think you understand why. It's because if y were equal to 0, you'd have this squared term here equal a negative squared term equal to a positive number. And that doesn't happen unless you're in the imaginary numbers. So the point is there's only going to be branches on the y-axis or in the y direction. So our graph is pretty easy. We don't even need to. There's no need to even plot points because you know that's an asymptote. And we know the vertex of the asymptote, or the parabola. The vertex of the parabola starts here, and as you go towards the left, it has to go towards that asymptote. So you just kind of draw it, kind of going right towards it. And it looks like a parabola in some sense, except for it goes towards, it's curvy. I mean, it has this little curve to it, you know. And make it look pretty. Mine looks awful, but there's one branch kind of going that way. The other branch, well, it's got to do the same thing. It's got to go towards, it doesn't ever really hit the asymptote. It gets really, really, really close to it. So there's the graph. Now there's just a few things we need to do. We need to find the focus points. So that requires us to use this relationship. C squared is equal to A squared plus B squared. And so we have the A squared and B squared. They're sitting, whoops, they're sitting right here. This number and this number are your A squared and B squared. So in this case we get 9 plus 4, which equals 13. And so this then would tell us that C is equal to plus or minus the square root of 13. Now, probably, for all practical purposes, you just find the decimal.
13 and 3.6.
3.6? I'll just take your word for it. And the focus points always have to be inside the branch somewhere. I mean, they're on the axis of the transverse axis, which in this case is the y-axis. So it looks like the focus, you said, is 3.6? Well, that means the focus would be right here, and it would be right about here. It's pretty close to where the vertex would have been. The vertex would have been right here, and if I would have drawn it better, it wouldn't look so awful. But anyhow, the focus points are basically right here, F1, F2. All right, now on your problems, what you have to do are just a few other things here. So on your homework assignment, on the book assignment, also in your study guide, there's 3 things they're going to ask you to do. 1, they want you to state the vertices. So what are the vertices? So the vertices, we'll do that first. The vertices, you're going to say, well, the x coordinate is 0, and then we can do our little shortcut by doing plus or minus. It's at plus 3 and also at negative 3, right? So plus or minus 3. So there's our vertices. The other thing they're going to ask for are the foci. So we can put in our focal points. And again, it's going to be 0. And this time we're going to say, how about plus or minus the square root of 13? Because one of them is up this way. That's the positive square root 13. That's the negative square root 13. So there's those. The third thing they're going to ask is, what are the equations for these 2 asymptotes? Okay, now you can look on your cheat sheet to try and figure that out, but it's actually quite easy, because the asymptotes, I'm going to write it out here. Hopefully you don't think too hard about it, because it's not that hard. It's basically y is equal to plus or minus mx plus b. Well, in this case, since the asymptotes go through the origin right there, there is no b part. So all you have to do is figure out the slope. Well, if you look at the box itself, you can calculate the slope. Here you go this way, and here you go this way. There's your slope right there. How far is your run? How far is the run? Well, hopefully you can see here, the run is 2. Okay. How much is the rise? 3. Okay. So the slope is 3 over 2. So the equation of that line then is simply plus or minus 3 over 2 x. And so it's not really that hard to find the equations of the asymptotes. Now why is it plus or minus? Well, because you have one asymptote going this way, that's the positive one, but then you have the other asymptote going this way, which is your negative one. So you have plus or minus 3/2 x. And there's your asymptotes. So after you get done doing all these steps to get the graph, then you're going to go through and get these 3. Okay? The whole process, I'm hoping, will take you less than 5 minutes. You want to be able to do it, hopefully, in about 3 minutes. That's reasonable. Once you're under 3 minutes, then you've probably learned it well enough. The sequence of steps. You're going to have to do it for a while. It's like just anything else. Don't expect to see me do one example and then say, oh, I've learned it. It's just like me showing you how to tie a shoe. You're going to have to practice it several times. So, anyhow, you get several opportunities on your study guide, and you'll get opportunities on the book assignment as well. So hopefully as you go through that sequence of steps, you kind of get it down. Okay, so now let's continue with our PowerPoint, because sometimes you have to work backwards. And so let's take a look at a couple of those problems. What if we have to work backwards now? Let's move on. There's the problem we did yesterday. And we did. Now, let's do this type of problem. What if we have to write the equation of the hyperbola? Remember, we did these with the ellipses as well, right? They give you... Well, what is it? We can say, first of all, we have to decide which one's the positive one and which one is the negative one. And we're going to have an equal sign over here, equal to 1, right? Now, this might be x squared, it might be y squared over here. How do we decide? Well, the foci are on which axis?
C.
That's the x coordinate. So that means it's on the x-axis. So if you don't have to graph this, but if you were starting to graph it, you'd realize the focus is at negative 8, 0. Well, that means this is your transverse axis, which means that only happens if the x squared is the one that's positive. Does that make sense? And so what we've identified for you is the C value. That's your C. Well, if that's your C value, then what's C squared? Quickly, you should say 64.
92.
Not 92. Hit them. Okay, so we figured out 64. Now, we're also told that we have some vertices. Well, notice that's on the x-axis also. And so this is your A value. This is the one that goes under the x squared. Okay? So if that's negative 5, which would be, say, right about there, right about here, then this is your A value, and that means A squared is equal to 25. So you now know this value is 25. And so you have y squared over here. All we have to do is figure out this one. Well, often to figure out that one, you have to use this equation we've been talking about. C squared is equal to A squared plus B squared. You see? And we know the A squared is that. So we're going to put in 25 here. We know the C squared is this one. So put 64 there. And that will allow us to solve for B squared. And just subtract 25 here, subtract 25 here, and we have determined what B squared is. Now, some people aren't thinking too sharply. They just start going about things automatically. And some people will go ahead and take the square root and they say, oh, B is equal to plus or minus square root of 39. Is that what we need?
No.
No, we actually need B squared. So just stop right there. No point in going further. Because we want the equation, right? Well, the equation asks for B squared here. So up here, we'll simply erase this and put in our 39. And now we have the equation. So this is how we work backwards. Notice we didn't really have to draw in the graph. I just put this in to help me realize I'm on the x-axis, which means this is my transverse axis, and that means the y-axis would be my imaginary axis. And we've accomplished what we were trying to do, the equation of the hyperbola. That problem is a little bit easier, isn't it? That one I hope you can do in less than a minute. About a minute, maybe 2 if you're really relaxing. If you're having Oreo cookies with milk, it might take 2 minutes. Okay? Alright. So, now, these problems you should expect on the day of the test. They're going to give you some sort of application problem. The parabola problem, the ellipse problem, the hyperbola problem, they're all very similar. The first step is to come up with the equation, and then usually you have to plug in some point. Somewhere you got to plug in a point to solve for a depth or a width or something like that. So let's take a look. It says a military plane is flying along a hyperbolic path. Now it's interesting that they're taking a hyperbolic path. I'm not sure how you train a pilot to do that. Maybe it's on autopilot. But there might be a good reason for going in at a hyperbolic path. It might make it harder for radar to pick it up. Does that make sense? You partly of what your goal is when you're using a submarine or an airplane or whatever is to go in and not be noticed. And so that might be the reason why they're going at a certain path. I don't know. I'm not into intelligence, but let's make up a reason that they're trying to go in secretly. And maybe flying in at a hyperbolic path will make it harder for radar to pick up. Could be. I don't know. Okay, so anyhow, they give us some information. They have some focus points, and they're going to go through this point here, the center of town. Below is the flight path located at X. Write the equation for the path of the plane. How high is the plane when it's directly above the center of the town? This is where the town is. So we're going to want, what we're going to want is this height right there. Maybe I should do that in another color. We want to know that height there. From here to here. Does that sort of make sense? We are after that height. So the first step we're going to want to do again is, by the way, because this hyperbola is opening up along the y-axis, I'm going to say y is my transverse axis, and I'm going to say x squared, and then I have this equals 1 again. So all we really need to do is figure out this number and this number. So hopefully based on this information, well, there's my focus point. So that means C is equal to 2 square root 3. So what's C squared? Well, the easy way to do this is just put this in your calculator and square it. But if you're going to square something, okay, if you're going to square something, it's the same thing. It's the same thing as just multiplying by itself again. So let's just multiply by 2 square root 3 again. What's 2 times 2? We'd say 4, right? And what's square root 3 times square root 3? 3. Don't say 9. That would be square root of 9, which equals 3. So C squared is actually equal to 12, right? Alright, well now we know...
Continue doing the math, because it will be 9, and then it'll turn back to 3.
It wasn't done yet. Alright, well now we know this distance here. This is the A distance. So A is 2, isn't it? So A is equal to 2, so A squared then is equal to 4. Alright. That means we figured out this part of the equation. That's 4. We have yet to figure out this part. Well, by using this piece and this piece, what? We should be able to figure out B, because remember, it's just like the previous problem. C squared is equal to A squared plus B squared. Okay? So in this case we get, shh, keep quiet please, I'm trying to finish this up. 12. I have a 4 over here, plus or minus, plus B squared. Now naturally if you move the 4 over there, you get B squared is equal to 8. Okay, so now we figured out this part. This part here is 8. So you figured out the equation. That's always, on these types of problems, that's always the first step. You got to get the equation. The second step is to, step number 2 is going to be plug in some point. Plug in a point. You're going to plug in a point somewhere. So you're going to have to figure out some coordinates. And what we know based on this picture down here is some information. we're trying to figure out the coordinates of this point right up here. So what coordinates do you know? Well, the truth is we know the x coordinate because it's drawn right here. The x coordinate is 3. It's the y coordinate that we don't know. In fact, the y coordinate in this case is the height right here. Isn't that the case? So now what you do is you take this information and you plug it in up here and here. Okay? So let's go ahead and do that. In this case, maybe I could use a different color. I'll use my cool purple color. I think this is kind of cool. Everyone can you see that color okay? So the y coordinate is what I don't know. So that's going to be y squared over 4. The x coordinate, I'm going to put a 3. I'm going to put a 3 right there. So that's going to be minus 9 because 3 squared is 9. And I have this is over 8 is equal to 1. Now I just need to do some fancy algebra. Ooh, that's kind of ugly, isn't it? I need to do some fancy algebra. Maybe I'll use yellow instead. I'm going to solve for y squared. So the first thing I want to do is move this fraction to the other side. And so I'm going to add 9/8. And I'm going to add 9/8 over here. And that gives me y squared over 4 is equal to 1 plus 9/8. Well, if you think of this as 8 over 8, remember it's 1, so I could write it as 8 over 8. If I take 8 over 8 and add it to 9/8, I get 17/8, right? So I'm just doing some basic algebra. If that step is intimidating for you, use a calculator. But now to solve this equation, I want to multiply this side by 4. I want to multiply this side by 4. And so I'm just continuing down the line here. The 4's then cancel out here. I get y squared is equal to, by the way, the 4 here, the 4 will cancel off with this 8 giving me a 2 down here. And so I have 17 halves. Well, now I take a square root here and a square root here. And so we can simply say y is equal to, and what I'll do is I'll just do this in my calculator. 17 divided by 2. Then take the square root. I get about 2.91547. And what is this unit that we're measuring in? It looks like it's miles. So at this point, we're going to say y is equal to about, we'll use the approximation here, 2.9 miles above. Now, they might want to know that because they might be planning to drop packages like,
Nuclear bombs.
well, it might be nuclear bombs. And they want to be high enough to be away from the explosion, right? Or it might be some packages that they're trying to drop, but they should try to get lower so it doesn't break all the packages into pieces, right? Maybe they're dropping water, maybe they're dropping food, maybe they're dropping toilet paper or whatever, you know?
Oh, there was when I was working, there was a couple airplanes that were just flying around. And
Yeah.
then all of a sudden, they just started throwing like crates in the sky. You just get the parachute go off.
Yeah. Yeah. They might have to be at a certain height to do that, though. So I would admit this problem is a little bit hokey, but we did solve the problem. And you should expect a similar type of problem on the test, where you have to come up with the equation first and then plug in a point. Now, it might be a hyperbola type problem, or it might be a parabola type problem, it might be an ellipse. You're going to have to come up with the equation first, and then you're going to have to plug in a point. That's how those problems work. Okay, so let's see, what else is there left on my lesson? I think we're getting pretty close to finishing the thing. Here. I think we're getting pretty close to finishing. Oh, what I wanted to do was just show you comparisons. One of the big comparisons with ellipses, for example, is this equation. For ellipses, and I'll just call it ellipses, one of the key differences is that you have c squared is equal to a squared minus b squared. with ellipses, a squared is always bigger than b squared. In this case, you'd say a is bigger than b. For hyperbolas, we could say that the c squared is equal to a squared plus b squared. And all that we can say here is that, a and b, we don't know which one's bigger. But we do know that the transverse axis is the positive one, and the imaginary axis is the negative one. Well, I think that kind of wraps up what I wanted to say about these hyperbola. I do believe you have enough information now to work on